Okay, so we're doing section 8.1, simplifying rational expressions. Inside the word rational is the word ratio, and ratio means fractions, right? So we're going to be simplifying fractions in this section. Before we begin, I just want to ask you, how do I simplify the fraction 4/6? Well, what's the answer? 2/3, right? And how would you explain to somebody how to actually get 2/3? We divide by 2 in this case, right? So divide by 2, divide by 2. That's how we get 2/3, right? That's what we're going to be doing today. But instead of division, I want you to think of multiplication, right? So instead of 4, I would like you to think of 2 times 2. Instead of 6, think of 2 times 3. And then, now that we have multiplication, now you're able to cancel the 2 and the 2, because 2 divided by 2 is 1, leaving you the answer 2/3, right? So I want to slightly change your thought process here, because when we get to polynomials, we're going to want multiplication to be able to cancel things out, okay? Let's jump right into the notes. And on the notes, it starts out saying that everybody knows that a fraction x over x equals 1 because the x's cancel out, right? Or 3 divided by 3 equals 1, or 5 over 5 equals 1, or whatever over that same exact whatever equals 1. We also know that x to the third over x to the fifth equals 1 over x squared, because you cancel out 3 x's with 3 of these 5, leaving you 2 left over on the bottom. Now, that really comes from it being expanded like this. X to the third is 3x's being multiplied. X to the fifth is 5x's being multiplied. And of course, now that you have multiplication, you could cancel out the x's, the x's, the x's. There's nothing left up on top. So that's why there's a 1. And there's 2 x's on the bottom. That's why there's an x squared on the bottom. So the reason why we're able to cancel out x's is because of the multiplication that was there. You see, we are able to cancel out terms because of multiplication. As a matter of fact, in order for you to cancel out terms, you need multiplication, right? If you have addition or subtraction, you cannot cancel, okay? So you need multiplication. Let me give you an example of that. We kind of just did an example of that. 4/10, you could rewrite that as 2 times 2, and 10, you could write it as 2 times 5, and the 2's cancel, giving you the answer 2/5. But if you had addition or subtraction for that matter, you cannot cancel the 2's right there. Does that make sense? Right here you cannot cancel. Like we already know this is a 4, this is a 7. The answer is 4/7. The answer is not 2/5. You can't cancel that and say the answer is 2/5. But if it were multiplication, then you could, right? If it were a 2 times 2 and a 2 times 5, then yeah, you could cancel out the 2's and the answer would be 2/5. But because there's addition, or even if there were subtraction, you cannot cancel. Okay, so let's understand that you need multiplication in order to cancel. Even right here, x plus 3 over x. X plus 3 over x, the x's cannot be canceled. Why not? Because of the addition, right? Now, what if I would have had a 3x over x? Could I cancel out the x's there? Heck yeah, right? Because there's multiplication, right? So right there you could cancel and the answer would be 3. But over here you cannot cancel the x's because of the addition, okay? Even right here, where you're like, oh, I want to cancel out the 2x with the 2x. You can't do it. Why not? Because there's addition. If there's ever addition or subtraction, you cannot cancel. You need multiplication, all right? So this is where the skills of factoring that we were reviewing yesterday come in handy. Because factoring is where you had like the answer and you want the multiplication problem. Factoring will give you a multiplication situation. So for example, right here, 2x plus 2, I could factor something out of that binomial, like a factor out the GCF. What's the GCF of 2x plus 2? 2. So I could technically pull out a 2 and I'll have something left over on the inside. What's left over on the inside? X plus 1, that's right. Now, because we have a 2 times out in front of my parenthesis right there that I factored, and I have a 2 times in front of the x right here, now I am able to cancel out the x's. Now, down here, I actually show that work for you. Check it out. It's nice and neat. I pulled out the 2, so now I really do have 2 times the binomial x plus 1, and on the bottom I have 2 times x. Because we have multiplication, we are able to cancel out the 2's, leaving us the answer x plus 1 over x. Okay, the answer is, so over here, then we could cancel out the 2's to give us this answer, x plus 1 over x. Now keep in mind, I cannot cancel out the x's. Why not? Because of the plus sign. Anytime you have addition or subtraction, you cannot cancel. Anytime you have multiplication, you can cancel. And that's why we're factoring, to be able to get multiplication, to be able to cancel. So let's go over here and review that key concept one more time. The key concept today is you can only cancel when we have multiplication. And we're going to use factoring to be able to get multiplication, right? So down here on number 1, you might want to cancel 3x and 3x, but that would be wrong, right? Because they're subtraction. So on every single one of these problems, let's factor first to be able to get a multiplication situation, then we could cancel. So what could we factor? We could pull out a 3 from the bottom, right? Now you could write it over here on the side, say 3, like that. What's going to be left over on the inside? X minus 3, right? And up on top, you're not going to do anything. You're just going to put it right there. And now on top you have 3 times x, and on the bottom you have 3 times the binomial x minus 3. Now that you have the multiplication, now you're able to cancel the 3 with the 3, leaving you your final answer, x over x minus 3. And of course, do not cancel those x's because there's a minus sign right there. Pretty easy, right? Okay. And you don't always have to rewrite your factored form on the side. Like if you wanted to, you could have just written it right here, put the 3 out there. You're going to have x minus 3 left over. And then you could like just put a line through it. That way you don't get confused anymore. You rewrote it to this. And then you could be like, oh, that 3 up there cancels with this 3 down there. So those guys cancel. And you'd have your answer x over x minus 3. Looking at number 2 right here. What could we factor on this one? If we had perfect square terms, maybe we could use square roots, but we do have this quadratic trinomial, and the a value is 1. And that was one of the easier problems to factor when we reviewed that yesterday, right? Whenever your a value is 1, let me just write down, a is 1, b is negative 1, c is negative 20. Whenever we had this situation, you just go parenthesis, 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 x, x. And we used to think what times what, or we do think what times what is a c value that if you combine together is the b value. So what times what is negative 20 that if you add together is negative 1. And I always say make a list, right? What is the list of negative 20? The multiples of negative 20 is negative 1 times 20, negative 2 times 10, negative 3 times, doesn't work, negative 4 times 5, there you go, and we're done. That's all the possible multiples to get negative 20 besides changing signs. Now, which pair of numbers combines together to give us the middle value, negative 1? Is 20 take away 1 negative 1? No, 20 take away 1 is 19. That's not 19. That's right. Negative 4 and 5, that's a positive 1. And we do have a 1 right here, but we want it to be negative. So we have the right number, just the wrong sign, which means we have the right numbers here, just the wrong signs. So let's circle that, but let's change that to a positive 4, change that to a negative 5. And we just pop in those numbers, plus 4, minus 5, and we have factored. So notice, I didn't write my factored form over here to the side. I wrote it right below. So since I already rewrote this to those binomials being multiplied together, I'm just going to put a line through it so I don't get confused on the denominator. But what I really do have is x plus 4 on top over x plus 4 times x minus 5. I really do have multiplication down here. And because I have an x plus 4 on top and an x plus 4 on the bottom, I'm going to cancel those out. Now, I am not, it's not right to think, oh, I'm going to cancel out this x with that x, and then this 4 with that 4, because that's incorrect because you have addition going on. What you want to think is, I'm going to cancel the entire binomial, the whole thing. I want to cancel it with this whole binomial, the whole thing with the whole thing. That's okay to do. Okay? So what is our final answer here? What's left up on top? A 1. Okay, and on the bottom? X minus 5. So again, if this canceled with that, I mean x plus 4 divided by x plus 4, that the answer is 1. So even though there's nothing up on top, you're going to put a 1 up there, okay, over x minus 5. Now, maybe in the future, I'll ask you what value would make this expression undefined? What value would make this expression undefined? So x cannot be what? X cannot be 5, because that would make it 0, which would make it undefined. That's not on today's assignment. It's not on today's homework solutions. But in the future, I will ask you for values that make it undefined. So just keep that in mind. Anyways, that's your answer, 1 over x minus 5. Now, that's barely the first, not even the, let's say the first half of the lesson. There's technically even a backside to this, but I didn't print it on your worksheet, okay? We're gonna wait till later to move on to the rest. Right now, all I wanna do is get really good at looking at a single fraction, factoring to be able to get the multiplication, to be able to cancel it out, all right? So we're gonna focus on that today and tomorrow, okay? And then later on Thursday, we'll move on, okay? But of course, like the two examples we did right here, these were easy because on this first one, all we did was pull out a GCF of 3. And on this one, it was really easy to factor a quadratic trinomial when the a value is 1. We have other factoring problems that are more challenging. Like what if that a value was like a 5 or a 12 or something like that? Then it would be more challenging to factor. So I think it's worth right now at this time to review some of those questions that have that multi-step factoring process. So let's all copy this down. 12x squared minus 5x minus 3 over 12x squared plus 4x. So again, today I want you to understand this. Factor everything possible. Factor everything possible. That way you get multiplication. Because once you have multiplication, then you could cancel. So I want to factor the numerator and the denominator. Which one's easier to factor? We'll start with that one. Bottom one? What could I factor on the bottom one? I could pull out a 4x, right? The GCF of 4x. Okay, so on the bottom one, and maybe instead of writing it to the side, I'm going to write it just right down here. I want to keep this right here. And I want to pull out a 4x, you guys said. So what's left over on the inside? 3x plus 1. Yay? Okay, so right here I'm just going to put a little line through it. You don't have to, but I'm going to put a line through it. That way I don't get confused. I already rewrote that denominator to be 4x times the binomial 3x plus 1. Now, what about that top one? That top one is going to require a multi-step process. Do we remember that multi-step process? Step 1 was to do what? A times c, that's right. And what is a times c? 12 times negative 3 is negative 36, right? Okay, negative 36. Okay, now what was step 2 in the process? Make a list of multiples of this guy, right? Of the negative 36. So let's make a list. Negative 1 times 36. Negative 2 times 18. Negative 3 times 12. Negative 4 times 9. Negative 5 doesn't work. Negative 6 times 6, right? Now, which pair of numbers combines together to give us the middle value, negative 5? 4 and 9. That's right. Okay, so if I add 4 and 9, that'll give me a positive 5. And I do have a 5, but I want it to be negative, so I have the right numbers, just the wrong signs. So change that to a plus 4 and to a minus 9. Okay, now, I don't want to turn this 5 into 2 other terms, making it 4 terms so I could separate it, so I could factor by grouping. I mean, I could do that, but there's a faster method that we practiced yesterday. That faster method, step 3 of that faster method was to set up, parenthesis, ax with a number. You guys remember that? Okay, so let's set up ax and ax. What is ax? In this case up here, what is ax? Is it 5x? Is it 3x? What is it? 12x, right? So let's write that down. 12x here, 12x there. Now, what about these numbers? Where am I going to get these numbers from? From the numbers from step 2, the positive 4 and the negative 9. I'm just going to put them right here, positive 4, negative 9. Pretty easy, right? Positive 4, negative 9. That was step 3. Now, I hope we remember step 4. That was the magical step. Step 4 is to magically, I'm just going to put magic divide. You magically divide by whatever you can. Okay, so this 12x plus 4, what could I divide by? 4, right? I mean, yes, you could divide by 2, but you want to divide by the greatest value. So you're going to divide by 4. If you divide by 4, what are you going to have left? 3x plus 1. Excellent. Okay, now, how about the other binomial? What could I divide by? 3. And if I divide both of them by 3, what do I get? 4x minus 3. And believe it or not, this is your factored form of the above. Okay? So I'm going to rewrite that top one. I'm going to rewrite it as 3x plus 1 times 4x minus 3. You know what? This did come out sloppy. Maybe I should have written it to the side. I'll write it to the side over here. That way it looks at least I can't even speak right now. It looks at least nicer. 3x plus 1, 4x minus 3 over 4x parenthesis 3x plus 1. And now that we have everything in factored form, that means we have a bunch of multiplication everywhere. Now we could cancel out whatever you see on top and on bottom that's identical. So I have a 3x plus 1 that's identical with the 3x plus 1. That cancels out, leaving us our final answer, 4x minus 3 over 4x. Should I cancel this 4x with that 4x? Heck no. Why not? Because there's a minus sign, right? You need to have pure multiplication in order for it to cancel. So there's your answer. Any questions on this? No? That's a lot of work. That's as hard as it gets, right? So I want you to practice with a portion of the homework assignment from the book. But before we do that, let's do one more. Write this one down. So as you could see on the top, on the numerator, we have an a value of 5 again. So we're going to have to do that same multi-step process. And you really need to know all the skills that we reviewed yesterday on factoring this denominator. How could I factor this denominator? Anybody? Yeah, you have a perfect square term here, perfect square term there. You could square root, right? To plug it into your answer format. So I am going to rewrite this entire fraction over here. But instead of 25x squared minus 36, I want to put my parentheses. I'm going to square root 25x squared. What's the square root of 25x squared? 5x. And then what about the square root of 36? 6. And what signs do I need in here? A positive and a positive, a negative and a negative, or one positive, one negative? One positive, one negative. So we factored the bottom one. That was easy. Let's factor the top one, again, using that multi-step process. Why? Because the a value is 5, not 1. If it were 1, it's really easy. You just think what times what is c, that if you add together is b. But right here, we have an a value of 5. So what is step 1? And what is a times c? 30. What's step 2? Make a list of multiples of 30, right? So we have 1 times 30, 2 times 15, 3 times, 4 times nothing, 5 times, there you go. And that's it. Always go 1, 2, 3, 4, just think of what the multiples are. Now, which pair of numbers combines together to give us the middle value, in this case, 11? 5 and 6, and we don't even have to change any signs. 5 plus 6 is positive 11. We're ready to go. We're ready to jump to step 3. Step 3 is the setup, right? The setup. And what goes in the first part of your binomial? The ax. And what goes, 5x. All right, great. So I'm going to write down the 5x. 5x. And what goes in the second spots? The numbers, right? What numbers? These numbers right here from step 2. So that goes up here. 5 and 6. So plus 5 plus 6. Now it's time for step 4. What's step 4? Magically divide. Magic division. Okay, so I'm going to divide this first binomial by what?
5.
I got a 5x and a 5. Divide by 5. What do I have left? 1x plus 1. Great. How about that second binomial over here? What could I divide by? Nothing. I mean, you could divide by 1 if you want, but it's not going to change anything. It's still going to be 5x plus 6. And believe it or not, that's the factored form. So this top quadratic trinomial that had the a value of 5, I can now rewrite it as those binomials being multiplied together. That's what I'm going to do. X plus 1 times 5x plus 6. And now you look at this problem, and we do have 5x plus 6 up here and a 5x plus 6 down there, which means I want to cancel them. Boom, boom. Why? Because I have multiplication now, which I'm able to cancel now. That's why we factor, to be able to get the multiplication, to be able to cancel. And that leaves us with our final answer, x plus 1 over 5x minus 6. X plus 1 over 5x minus 6. You can't cancel out the x's because of the plus or the minus. You just can't cancel anything else out. We're done. Okay. So, like I mentioned a couple moments ago, I want to focus in just on this single portion of the section. So on the homework, let's just look at numbers 13 through 18, which is just a single fraction that you're going to factor wherever you can to be able to get multiplication, to be able to cancel. Okay. And you see, we're going to have I guess you could say I can't even speak right now. It's a pop quiz, but it's no longer a pop quiz because I'm telling you there's going to be a quiz. So it's a regular quiz tomorrow on this stuff, right? Probably not. So right here, I mean, let's go to number 18. That's a crazy one. I heard you say, what the? No, yeah, because that seems like it's crazy, but it's not. What do we? Yeah, exactly. Why? We have y's instead of x's. Yes. Look. You guys are thinking this is too much. It's not. All you got to do is go through each part of it and factor whatever you can. Because if you have pure multiplication, you could cancel things out. So even before, how about this? Even before factoring, is there anything I could cancel? You see, this says 3 times y times something, right? Now, if I had a y minus 8 somewhere down here, I'd be able to cancel it out, right? But I don't right now. But I do have a 3 times y, and I have a 15 times y, and the 3 and the 15, that could cancel.
Isn't that y squared?
Yeah. But see, here's the, let me push this to the side. Let me ask you this. 3y over 15y squared. You could reduce that, right? The 3 and the 15, that becomes a 5 left over on the bottom. And what about the y and the y squared? The 1y on top cancels with one of these y's, and you have a y left over on the bottom. So you could most definitely cancel the 3 and the 15, leaving you a 5. And you could most definitely cancel this single y up here. You could cancel that single y with one of these 2 y's. Right? Okay, so let's let me make some space, move this over. So let me continue rewriting my fraction right here. Up on top, the 3 canceled, the y canceled. I could write a 1 if I want to. I don't have to. But what do I have left up on top? I have the binomial y minus 8. And then I have this guy. That's a quadratic trinomial where the a value is 1. The only difference is instead of x's, I have a y. And how do we solve this before? Or how do we factor this before? We would say, what times what is your c value? That if you add together is your b value. And we would even make a list. And we're going to make a list. The multiples of negative 24. Okay. So up here, negative 1 times 24. Negative 2 times 12. Negative 3 times 8. Negative 4 times 6. Negative 5 doesn't work. That's it. So which pair of numbers combines together to give me the middle value b? Negative 4 and 6. You don't even have to change any signs. So let's put the negative 4 right there, the positive 6 right there. and we have factored that above quadratic trinomial. So down here at the bottom we have a 5, we have a y. I might as well write that. 5 with the y. And then this quadratic trinomial, I'm going to do this one, underline it in blue. This quadratic trinomial, I'm going to rewrite that as those sets of parentheses, and we're going to factor it. Instead of x's, we have y's, but same process. What times what is c that if you add together is b? So again, I'm going to make a list of the multiples of 32. 1 times 32, 2 times 16, 3 times, doesn't work, 4 times 8, 5 doesn't work, 6 doesn't work, 7 doesn't work. That's it. There's only 3 possibilities here. So which pair of numbers combines together to give us the middle value negative 12? 4 and 8, right? 4 plus 8 is 12, but we want a negative 12, so we have the right numbers, just the wrong signs. So change that to a negative 4 and a negative 8. Plug in that negative 4, plug in that negative 8, and you're good to go. Now everything is factored. Now we could look and see what is identical on top and on the bottom. What could I cancel? This y minus 4, I could cancel with that y minus 4. And this y minus 8 over here, I could cancel with that y minus 8. So let's do that. Let's cancel out the y minus 4. Whoops, need a pencil, not a highlighter. Y minus 4 cancel with the y minus 4. And the y minus 8 cancel with the y minus 8. So my final answer is y plus 6 over 5y. So this is all we want to practice. So for the rest of the class, I would expect you guys to be able to go back and do the rest of these. You know what? In other classes, I've seen students freak out with number 15. Look, first of all, the denominator on 15, there's nothing to do, right? It's already in factored form, right? You got an x plus z, you got an x minus 3, there's a 4. You can't pull out a GCF. You can't factor. This is already factored. This guy could be factored, and this guy could be factored. What is x squared minus 9 factor to? So I'm going to factor this right above right here, just so I don't have to rewrite it separately. What does that factor to? X plus 3, x minus 3, right? Okay. One way of thinking of it is what times what is a c value negative 9 that if you add together is a middle value 0 because there is no middle value. That would be a positive 3 and a negative 3. Another way of thinking about it is recognizing that this is a difference of two perfect squared terms. The square root of x squared is x and the square root of 9 is 3. So you put x and 3, one's plus, one's minus. So over here you have a difference of two squares. So what does this factor to? What does this guy factor to? Parenthesis. X, z. One has to be a plus, one has to be a minus. And now that everything's factored, the x minus 3 up here cancels with that x minus 3 down there. The x plus z up here cancels with the x plus z down there. And your answer is, I ran out of space, x plus 3 times x minus z over 4. Okay? Man, so I already did, 30% of your homework. Do the rest, because we're going to have a quiz that's going to mirror this stuff tomorrow.